Hello, and welcome to this FMSP Core Prerequisites video. These videos are designed to help you to get ahead with independent study of the A2 core, ready to develop the skills in A2 Further Pure modules. This is what you should know already. Do check out the first vectors video before continuing with this one to make sure that you don't have any gaps. And do any necessary consolidation work too, so that you are confident with the ideas. You'll need these things as you work through the video, so pause the recording now and go and get everything together. Make sure you've set aside enough time to do the questions as well as watch the video. This is what we'll be covering in this video. The magnitude of a vector is just its length. When you've got a vector in component form, you can just use Pythagoras' theorem to find its magnitude. It's just like finding the modulus of a complex number and uses the same notation. So here we have the vector -3, 4, and we know from our Pythagorean triples that that means that the hypotenuse of that triangle is 5. So we say that if this is the vector AB, then would say that the vector AB is -3, 4, and the modulus of the vector AB, or its magnitude, is 5. Okay, you have a go at this one. Pause the video and work out the answer before you watch the solution. Okay, the vector AB, to get from A to B, well, to get from -2 to 2, I need to go forward 4, and to get from 3 to -5, I need to go back 8. So the vector AB is 4 minus 8, and the magnitude of that vector is 4 squared plus 8 squared, all square rooted. That's the square root of 16 plus 64. Square root of 80. You could simplify that using a calculator, but it's great if you can do it without. 80 is 16 times 5, where 16 is a square number. So that's 4 root 5, which is C. Okay, sometimes you want a unit vector. That's just a vector which is of length 1. So to find a unit vector in a particular direction, start off with any vector in the right direction, find the magnitude of that vector, and then divide that vector by its magnitude, and the resulting vector will be the right size. Here we've got the vector 12, 5. So that's a vector in the correct direction. The magnitude of this vector is 5 squared plus 12 squared, all square rooted. That's root 25 plus 144, which is root 169, or 13. Or you might have spotted that that was the well-known Pythagorean triple 5, 12, 13. So a unit vector in the same direction is 1/13 of 12, 5. And here's a couple for you to check. So pause the video and try this yourself. Okay, this is another 3, 4, 5 one, so we know the magnitude is 5. So a unit vector is 1/5 of -3, 4, or in IJ notation, -3/5 in the I direction, plus 4/5 in the J direction, and that's B. One last example. We're in 3 dimensions here. Again, pause the video and try it yourself first. Okay, the unit vector in the direction of CA. So if I'm going from C, that's this one, to A, that's that one. So from -1 to 2 is plus 3. From 5 to minus 1 is minus 6, and from 2 to 0 is minus 2. So the vector CA is 3 minus 6 minus 2. Next we find its magnitude. That's the square root of 3 squared plus 6 squared plus 2 squared. That's root 9 plus 36 plus 4, which is root 49, which is 7. And therefore the required vector is 1/7 of 3 minus 6 minus 2, which is 3/7 in the I direction minus 6/7 j minus 2/7 k. And that's A. Well, that's all for this very short topic. Don't skip the consolidation. Make sure you do enough questions to be really confident with this aspect. I hope you found this video useful. The next one continues with vectors and looks at the vector equation of a line. Goodbye.